Right. I think we're all set up and good to go on TikTok Live and YouTube Live. Just going to give people a few minutes to join before we get started. I've been experiencing technical difficulties in the past, so just wanted to log on a little bit earlier to work those out. We will get started at 3. Hello, everyone. We will get started here shortly. Just waiting for a few more people to join. These sessions are recorded, so we'll go through these practice problems today. And if you want to go back and look at what we reviewed today, you can always go to the channel and look at previous live streams. Congratulations, Tyler. That is so exciting. When did you take it? Nice. Everyone, Tyler passed his FE exam. Now you don't have to worry about that. What did you use to study? Oh my gosh. Yeah. Some people love to do the FEPE back to back. I took a break personally. I think it was 2 years in between, but you're already in study mode, so might as well dive into the PE. Hello, everyone. I logged on early today so that I could work out all my technical issues. So we should be good to go. Um, I think I'll get started like at 3:05 just to give people time to join. But yeah, everyone, Tyler passes FE exam and he's going to be studying for his structural PE now. Is anyone else taking their FE exam soon? Oh, nice. Is that one on Amazon? Hey, John, thanks for joining. Down. All right. Happy to see some people hopping on TikTok Live and YouTube Live. If you're joining on TikTok, you will have to go ahead and go to YouTube Live to be able to see my screen. TikTok does not let me stream my iPad. So, yeah, if you actually want to see the practice problems I'll be going through, you can go ahead and join on YouTube Live. Um, but yeah, Danny, hi. Physics. Yeah, physics is definitely part of the FE exam. If you're joining on TikTok, go ahead and join on YouTube Live as well so you can see my screen. I'm going to start sharing it now. I got all my technical difficulties ironed out today, so we should be good to go. I am starting to share my screen now. Hopefully you all can see it. But we'll get started here in a minute. This first practice problem is going to be going over vector operations, which is a part of the mathematics section. I'm preparing my statics module, so I've been doing a lot of vector operations, statics problems, so definitely wanted to include those in today's session. And I tried to make it as realistic to real life engineering as possible. So this first one you'll see has to do with a traffic light or traffic signal, because if you do go into transportation, these are things that you'll have to consider, just the structural integrity of your traffic pole and signal and all of that. So yeah, it's 3:05, so I'm gonna go ahead and get started because like I was telling you guys last week, I want to start going through more practice problems so that you guys get all the practice that you need before you take your FE exam. It also helps me, I do tutor full time, so it gives me practice just teaching you all how to go through these problems. So yeah, problem number one, mathematics. A traffic signal is supported by a horizontal boom attached to a vertical pole. The signal has a weight of 300 newtons. The position vector from the pole's base at point O to the signal is given. And then the force vector, which is the signal's weight, is also given. So the question is asking us to determine the moment of the force about point O. And just making sure I stay up to date in the chat. So, someone said how to study for the FE exam. I bought a course that requires me to study 15 hours a week. Um, so I would suggest if you're just starting to study for the FE exam that you purchase a practice exam off the NCEES website. Go ahead and block out 6 hours to complete the exam. Go ahead and score yourself so you can see where your areas of improvement are, what areas that you're pretty good in, so that you can develop a study plan from there. And then I think you do need to dedicate at least 3 months to the FE exam. I think you need a little bit less if you are taking the classes, obviously, and everything's fresh in your mind. But if it's been a while, I definitely recommend spending 3 months studying for the exam. Someone asked if I passed the FE. Yes, I'm a licensed professional engineer. I got my license in May. So I've done the 4 years of engineering. I passed the FE and PE exam, and I am allowed to stamp plans. And then someone said, which, to be honest, I study for one, then completely abandoned. Um, Yes. So the goal of my channel and just the content that I'm creating is just to try to make studying for the FE a little bit more entertaining, make it clear. I know I've tutored a couple of students who said that they've had tutors, and sometimes it's been hard for them because their tutor has a thick accent or their tutor hasn't passed the FE or P exam themselves. So I'm a professional engineer who wants to provide fun, clear explanations for the FE exam. Raul said, does this include mechanical FE exam? I think there are some overlapping topics, but I am a civil engineer, so these videos are civil focused. Someone did ask me to do an electrical topic because they're an electrical engineer, which I may do in the future, but we're definitely keeping the civil focused. But yeah, I think I answered all the questions. So I'm going to go ahead and get back to the practice problem. If you're joining on TikTok, go ahead and hop over to YouTube Live so you can see my screen. So we're given the position vector R, and we're given the force vector F, and we need to determine the moment about the force moment of the force about point O. So when you're given two vectors and uh, you're in 3D space, to determine the moment about a certain point, you will need to use the cross product. Hey T, thanks for joining. Nice to see you again. It's nice seeing some repeats in here. So yeah, in order to solve this problem, we need to do the cross product. So again, if you are following along, make sure you have your FE reference manual, something to write with, and your NCEES approved calculator, because this will help you get better practicing for the exam. So I'm going to go ahead and go to the FE reference handbook. I'm already in the mathematics section. So we're going to go to the cross product. So this is the vector section. The FE reference manual is searchable, so you can just search for vectors. And so yeah, we'll be doing the cross product. As you can see, the result of a cross product is going to give you a vector from the FE reference manual. It is telling you to basically do a determinant of the two vectors that you're given, but the name of the game on the FE exam is speed. So instead of trying to do or perform the determinant and figure all that out by yourself, you can actually just use your calculator. Your calculator is a very powerful tool, and if you know how to use it, you'll be able to get through the questions on the FE exam a lot faster. So we're given two vectors and we need to do the cross product to determine the moment about force O. So I'm going to go ahead and show you guys using my calculator how I'm going to solve this problem in less than 3 minutes. On the FE exam, you'll have about 3 minutes per question to 3 minutes per question. So you want to make sure that you're able to do the problems within that time frame. So I'm using the TI 36X Pro on YouTube. I'm going to go ahead and switch over to my webcam. So it's clear right now. I'm going to press the second button and go to vector, which is right here. If it focuses, there's an EE button, and above that in blue it says vector. And then it'll bring up this screen. So you're able to input the vectors here. So I'm in the names column, but I'm going to go to the edit column by hitting this arrow. And then I'm going to go down. So right now we're on vector U. So I'm going to hit enter. It's going to ask me how many dimensions This is a three-dimensional vector. When you see three places in the vector, that means you're in 3 dimensions. So I'm going to hit OK. So I've already input the numbers for this, but as you can see, the first number is 4, the second is 0, and the last is 6, like we're given in the problem. I'm just going to go back so you all can see. And then I'm going to hit the second button again, go to vector, and scroll down, or go to edit again, scroll down to 2, which is the V vector, the vector V. I'm going to hit enter, tell it it's 3 dimensions, hit OK. And then I've already input those numbers, which are 0, 0. And then it's negative 300 because the weight of the signal is going downwards. So I have those numbers all in my calculator. I'm going to hit enter. And then I'm going to hit second and hit vector one more time. And then when you go to the math section, it lets you do dot product or cross product. So we're going to do the cross product. That's not what I wanted. Sorry, 1 second. So hitting second, going to vector, going to math, cross product. I don't know why it's taking me there. 1 second. So I hit clear a couple of times, second vector, go to math, cross product. Okay, so hit clear a couple of times and then hit second, hit vector again, go to math, go to cross product, and it should bring you to this screen. So now we need to tell the calculator what vectors we wanted to do the cross product for. And again, you want to practice so you can get really fast at this, so you don't have to solve it on your own on the exam. So we need to tell it we want the cross product between vectors u and v. So I'm going to hit second. I'm going to go to vector. I'm going to hit under the names column. It's selecting, I'm going to select u. So I'm hitting enter. So hopefully you all can see that. I'm going to put a comma by hitting second and hitting the period down here. And then I'm going to tell it to cross it with the v vector by going to second vector, scrolling down to v, hit enter. So now we're telling it to do a cross product between u and v. I'm going to close the parentheses, hit enter, and it should give you this screen here. So it's 0, 1200, 0. So the moment about 0.0 is going to be 1200. That's what this number is giving us there. So just by plugging in these numbers into our calculator, we found the moment about the force to, or about 0.0 to be 1200. And the units of any moment is going to be a force by length. So in this case, it's going to be a Newton meter. Any questions about that? Yes, if you're joining on TikTok, make sure you go over to YouTube so you can see my screen. TikTok does not allow me to share my screen, so I am dedicating my focus to the YouTube live. So if you just search for Degree to PE on YouTube, you should be able to find the live. But yes, your calculator, very powerful. When I did this on my own earlier, it took me a minute. So that gives me 2 minutes back to make sure I have more time on more difficult problems, or if I want to go back and check my work, I can do that. Otherwise, if you don't know how to use your calculator, you're going to have to go through and find the determinant between these forces. So that's not fun. But we can definitely go over that at a later date, but I just wanted to show you guys how powerful your calculator is. Any questions about that before we move on? If you're joining on TikTok, make sure you hop over to YouTube so that you can see my screen. If there's nothing on that one, we'll move on to problem number 2, which is another math problem. And this time, the question is asking us to find the angle between the two given vectors. So G has a -5 I component and a +5 J component. H has a +2 I component and a +3 J component. So the I corresponds with the X direction, the J corresponds with the Y direction. If we were given a third term for these vectors, that would be a K hat, and that would be corresponding to the Z direction. But we're just in 2 dimensions here. So does anyone know how we find the angle between two vectors? Feel free to put it in the chat. If you're not sure, you can always go to the mathematics section of your FE reference handbook, see if any of those equations make sense. But I know that to find the angle between two vectors, you need to do the dot product. So we just did the cross product, which is one form of vector operations, and now we'll be doing the dot product. So you can search for dot product in your FE reference manual. And it should take you to the appropriate area. So you see that when you do the dot product between two vectors, basically you're going to multiply the two components together. So ax bx plus ay by plus az bz. And all of that should be equal to the magnitude of both vectors times the cosine of the angle between those two vectors. So I'm going to go ahead and grab this so I can bring it back to the practice problem. Copy, paste. All right. So, your calculator can also do this for us. So let's go ahead and practice inputting these vectors into our calculator. So again, to get to the vector section, you press second and you click on the double E. All right, and we're going to go to the edit section. This time we need to tell the calculator that we're actually in 2 dimensions instead of 3. And so what we'll input for vector G is -5. Hit enter. It should take you to the second slot where you can input the second number. So I put -5 there. I'm going to put a +5 there. Hit enter. Clear a couple times, and I'm going to do that again, but I'm going to edit vector V, which is also in 2 dimensions. The first number is 2. I'm going to hit enter. I'm going to hit 3, hit enter, clear a couple times. Second vector, we're going to go to math. Now that we have the 2 vectors edited in our calculators, I'm going to do the dot product. It's asking what 2 vectors do I want to do the dot product for. So I'm going to hit the second button, go to vector, there. I'm going to hit U, enter, put a comma. Then I'm going to do the same thing for vector V. Close the parentheses like that. Hit enter, and the result that you get after dot product is a scalar value. So it's telling me the answer is 5. So even if you did ax time or gx times hx plus gy times hy, you should get 5. If you are unsure, you want to check your calculator. Let's see. Okay. So the answer is 5. So A dot B, or sorry, G dot H equals 5. But we also need to find the magnitude of both vectors. So to find the magnitude of G, sorry, that handwriting was so bad. I can do better. G dot H equals 5 because we used our handy dandy calculator to figure that out, so we didn't have to do it by hand. Now we need to find the magnitude of G and H. To find the magnitude of any vector, you need to do the square root of its components squared. So in this case, it's going to be -5 squared plus 5 squared. And the magnitude of H is going to be the square root of 2 squared plus 3 squared. And then these sessions are a lot more fun when everyone is participative, so feel free to put your answers in the chat. You don't need to be afraid of being wrong. This is a safe space. The more you practice, the better you will do on the FE exam, and you're all here to help each other out. So I'm going to go ahead and type this into my calculator. So for G, I'm getting 5 root 2. And also, I am an imperfect human, so you all can make sure that I'm doing these problems correctly and we're all getting the same answer. Thanks, John. Okay, so for H, I'm getting square root 13. So we found the magnitudes. So we can set the result that we got from the dot product equal to the magnitude of G times the magnitude of H times the cosine of theta. And theta is what we're trying to solve for. All right, so that's going to be 5 root 2 times square root 13 times the cosine of theta. We are going to we're going to divide the magnitudes so that we can get them to the other side. So 5 divided by times square root of 13. 5 divided by all that is going to be 0.196 equals cosine of theta. So now we're going to do the inverse cosine. And you can do that on your calculator by hitting the cosine button twice, in case you're not sure. So yeah, cosine inverse of 0.196. I am getting theta equals 78.7 degrees. Is that what you all are getting as well? Hey, yes, we are doing FE Civil Exam Prep on TikTok. I'm not able to share my screen, but you can search for Degree to PE on YouTube. We have folks on the YouTube Live. That way you can see my screen. So this is what we're doing right now. So yeah, if you want to see my screen, make sure you join on YouTube Live. But yeah, we solved problem number 2. Okay, so any questions about problem number 2? If not, we will go on to problem number 3. Alrighty. So problem number 3 is construction engineering. We haven't done a construction engineering problem yet, so definitely wanted to throw that in there. The construction engineering section has quite a few topics on it. So you'll see questions about project administration, um, like documents management, procurement, project delivery methods, like design builds, stuff like that. Construction operations and methods, safety equipment, productivity analysis, temporary erosion control, project controls, such as like schedule, which is what this problem is. You'll also see some estimating, and you'll see some interpretation of engineering drawings. So wanted to throw a schedule problem in there. As an engineer in real life, schedule is very, very, very important to projects. Because I'm on the design side, we are often telling clients how long the construction timelines are supposed to be, and keeping track of all those things. You'll see Microsoft Project used a lot to make schedules for projects. So yeah, wanted to throw a critical path problem in there. Microsoft Project is also a really useful tool in industry. So if you have some time just to learn about it, like on LinkedIn Learning, I highly suggest that that be a program that you learn how to use. But problem number 3 is asking us to determine the critical path of the project, given the schedule below in days. So again, if you're joining on TikTok, make sure you hop over to YouTube Live. This is the problem that we're doing, this construction engineering problem. Okay, so each box represents a task. So A could be mobilized to the construction site. B could be, you know, lay out rebar. Depends on what kind of project this is, but I'm just using letters, and then the numbers correspond to how many days that task is supposed to take. The critical path, you can search that in your FE reference handbook. Critical path. Let's see. Okay, let me finish typing it out. All right. So critical path is just how long, what is the longest timeline between the starting task and the last task. So out of all of these pathways, which one has the longest amount of days? Um, it's really important to pay attention to the critical path because this item will hold up other items. So basically you just want to determine which pathways you could go. So we could go from task A to task B to task D to task H. You all see that? So we could do A, B, D, H, and then we just add up all of those days together. So that would be 5. Oops. Let's see. So that'll be 5 plus 7 plus 3 plus 2. Mental math. We're engineers. Anyone have an answer? 5 plus 7 plus 3 plus 2. All right, so that would be 17 days. If we took that path, another path we could do is A to B to E to G to H. So let's calculate how many days that would be. So A, B, E, G, H. So that's going to be equal to 5 plus 7 plus 9 plus 8 plus 2. Feel free to put the answer in the chat once you have it. 5 plus 7 plus 9. John is saying he's getting 31. That sounds right to me. So if we took path 2, it would be 31 days. And lastly, we could go from A to C to F to G to H. So we need to calculate how many days that is. So ACFGH, that would be 5 plus 4 plus 6 plus 8 plus 2. That's 10 plus 10 plus 5. So I'm getting 25 days. So the critical path, thanks, John. That's what I got. Thank you for double checking that. So the answer is going to be the option with the most days. So our critical path is going to be 31 days. So I'm just going to erase these. Yeah, this is our answer. Any questions on that? All right, I have one more practice problem for us today. And that is going to be on transportation engineering. Again, another subject we haven't gone over together yet, so definitely wanted to throw that in here. So problem number 4 is asking us to find the maximum flow rate of the highway using a level of service B and a speed of 60 miles per hour. So I am not a transportation engineer, so you know what I'm going to do? I'm going to go to the reference handbook and I'm going to search transportation. And it should take me to the transportation section. I think we're there. Okay. So, the problem is asking us to find the flow rate for the highway. So I'm going down to the traffic flow relation section. Hopefully you all can see that. We're given the green shields model. So the maximum flow is going to be Vm. So we need to use this equation here. And it looks like there are some other variables that we need to find out. So I'm just going to go ahead and cut this section out, bring it back to our practice problem. Copy. I'm going to paste that here. So we're looking for Vm. But to solve for the maximum flow rate, we need to find D of J, which I think is the jam density, SF, which I believe is the theoretical speed, and then we need to divide those values by 4. So to find DJ, we're going to use this equation here, and let me go ahead actually and grab what each of these letters means. Copy that, paste it over. So we're all on the same page. All right. So to find the jam density, we are going to use the optimum density equation. This DO equals jam density over 2. But to find the optimum density, we need to go back to the FE reference handbook and go to this table up here. So this is the level of service table. It shows the level of service and the density associated with that. So I'm also going to grab that, copy and paste it. All right. So we were told in the problem statement that it's a level of service B. So the density is more than 11, but less than 18. Is everyone following along there so far? Any questions on that? Okay. Okay. So, level of service B density is more than, or yeah, more than 11, but less than 18. So we are going to use the maximum density because the problem is asking us to calculate the maximum flow rate. So we are going to use 18. So this is going to be our optimum density value, D naught. So because we have that, we can plug that in for D naught. We know the jam density divided by 2 is equal to 18. So if we solve for the jam density, we're going to get 36. So now we found our jam density. Now we need to find our theoretical speed selected by the first driver entering the facility. So S of F. Oop, drop my pen. Okay. So to find S of F, we need to use this equation here. Let me use a different color. We'll go blue. Okay, so the speed we were given is going to be this S value here. So we know 60 is equal to our theoretical speed minus our theoretical speed over our jam density times D. I'm just going to plug in the jam density. And D is density, which is going to be which is going to be 18. So same as D naught. So if we solve for the theoretical speed, let's go ahead and do that. So I'm going to do 18 or divided by 36. That's 0.5. Hopefully you all can still see this. 60 equals SF minus 0.5 SF. 1 minus 0.5 is 0.5 SF. So we need to divide 60 by that number. So we get a theoretical speed of 120 miles per hour. So we found the jam density, we found the theoretical speed. So now we need to multiply those values together. So 120 times 36 divided by 4. So V, so our maximum flow for the highway is going to be 36 times 120 divided by 4. And you should get 1,080 vehicles per hour. Does that make sense to everyone? Any questions on that? All right, that's all I had for us today. Um, like I said, I am working on getting a statics video posted. So this will be an actual module of the FE Civil Exam Prep course. I've already uploaded video 1, which is everything that you need to know about the FE Civil Exam. So make sure you watch that before you register for your exam so that you know exactly what you're getting yourself into. And yeah, uh, I will be uploading a statics video here shortly. So I will be out of the country for the next 2 weeks. So we will not have live study sessions next week or the week after, unfortunately. But there are plenty of other videos on my channel that you all can watch. And I'm also putting together a list of some other channels I think would be helpful for y'all. But yes, that is where we're at. So no lives next week or the week after. I will be out of the country. But yeah, when I get back, we will start this up again strong. If you have any questions that you'd like to see me work through, you can definitely submit them at the link that I posted under my going live video. But yeah, no problem, T. Thanks for joining, John T. Nice to see y'all as always. Ryan, you are asking how I got 120. So, sorry you cannot see my screen on TikTok. If you go to YouTube, you will be able to see my screen. But 120 for the theoretical speed, we got that by using this equation here. So S is the speed we were given in the problem, which is 60, and we solve for the theoretical speed by plugging in 18 for D, the maximum density, and then for D of J, our jam density, we calculated that to be 36. Um, Unfortunately, I can't share my screen on TikTok, but these sessions that I do on YouTube Live are recorded, so you can go ahead and watch this video back on YouTube once the live ends, and you'll see exactly how I got all of the values. But hopefully one day I'll be able to share my screen on TikTok as well, just so it's not as confusing. But thank you for the like. Thanks for joining today. I will also be going live tomorrow, so yeah, feel free to join on YouTube tomorrow. But yeah, that's all I have for you guys today. Thank you guys for liking the lives. I think that helps the videos get pushed out to other civil engineers. Make sure you share with your other civil engineering friends so that they can all pass the FE as well. Someone let us know earlier, Tyler, he let us know that he passed his FE. So that's very exciting. And I hope everyone else studying for their FE exam passes as well. But yeah, I'm here to help. So feel free to hit me up on LinkedIn, TikTok, Instagram, YouTube if you have any questions. All right, guys, I'm going to sign off. Thank you.